All right, today in this lesson, we are looking at parent graphs. And what I mean by that is in the study of algebra, you have lots of different, there's so many relationships that exist in the natural world, and those relationships might be linear in how, say, one variable affects the other. X affects Y. So that relationship might be modeled in a linear manner. This is basically an Algebra 2 class, so in your study of algebra, you've looked at quadratic equations, which make that U shape, a parabola from like a quadratic equation. Okay, so you could have a line, you could have a parabola, you could have an absolute value shape, which is like a V shape. You could have what I sometimes call a snake graph, and it's a cubic shape. There's lots of different shapes here that model different relationships. And so our focus here in this particular lesson is to be able to identify parent graph of a given equation. So identify the parent graph of an equation, and then vice versa. So I give you an equation, you pick out the graph that matches, or I give you the equation and you pick out the graph. I don't know, vice versa. You get it. I may have just jumbled myself up, but so next we would be identifying the type of function that best fits the data that's given in, say, a scatter plot. Okay, so identify the function that best fits a scatter plot. Okay, so there's some ideas there. That's what we're going to be looking at here in this lesson. So every type of function has specific characteristics that make it unique, and for this class, for this lesson, we're focusing on these 8 functions: linear functions, absolute value, quadratic, cubic, sine, cosine, square root functions, cubic functions, exponential, logarithmic, and tangent functions. So let's jump into it. A parent function is the simplest form of a set of functions that form a family. A parent function is the simplest form of a set of functions that form a family. The simplest form of a family, right? So you get the basic function, and then from that basic function, then you get all sorts of variations. It's basically a starting point. The format of x, whether it's exponent, absolute value, or whatever, it determines the family. So the format of x determines the family. If you see the square root symbol of x, then you know the shape will look a certain way. If you see sine of x, then you know the graph will look a certain way. So, just a quick review of these parent functions. Probably the most basic parent function that you'll run into is a linear function, and the parent equation looks like this: y equals x. Obviously the description is a straight line, and the basic graph looks like this. if you think back to Algebra 1 or prior to that, y equals mx plus b. In this case, y equals mx plus b. That is y equals 1x plus 0 in this particular case. What does this mean? It has a slope of 1 and it has a y-intercept of 0. So it crosses here at 0, 0, and there's a rise of 1, a run of 1. Up 1, right 1, up 1, right 1, up 1, down 1, left 1, down 1, left 1, down 1, left 1, and so forth. Okay, so that's a line. You know the line. Absolute value, it's the same as the linear graph, except the left side of this graph, left of the y-axis, has been reflected upwards above the x-axis. Creates a V-shape. My goal here is, I'm showing you these things so that we can just briefly discuss them, and then the real task here for you is you kind of have to commit these to memory. There's some exercises that you can do, but it kind of just I'm giving you, this is like vocabulary. It's like when you're in elementary school or even now, you're taking those sorts of classes where you have to learn the vocabulary, because if you don't learn the vocabulary, then you have no idea what you're even talking about. Okay, so this is the vocabulary in this case are graphs, they're shapes, and you've got to just memorize this stuff. There's no other way around it. It's like if I gave you a vocabulary test, I would be asking you to define a certain word. Well, in this case, if I test you on these, your job will be, if I give you the equation, you give me the graph. If I give you the graph, then you give me the equation. That's how the vocabulary test in this case works. All right, so a parent function for a quadratic, y equals x squared. It's a U-shaped parabola. It looks like this. A cubic graph, this is what I sometimes call a snake graph. I don't know why I call it that, but I do. When you start looking at variations of this graph, the variations look like this. So you can see there's the idea of a snake there. Okay, so execute. That's the parent function. Square root functions. Think of a parabola, like x squared, right? X squared does this. Think about, think about like rotating it 90 degrees to the clockwise manner, and then cutting off the bottom half. It's not exactly that, but it's that idea. Okay, so this is a half of a rotated parabola, we'll say. Cube root. This is similar to the square root, except in this case, it's the second half is not cut off. Also, for me to say rotated, that's not exactly true. It's more of a reflection. Let me just say that, reflected. And let's just kind of cross this word out. Same thing here. If I took the cubic graph, which I just showed you, if I take this particular graph that I just drew and I rotated it, it will never line up with what I have printed here. So that's what I'm saying. It's not rotated. There's more of a reflection going on. It's reflected across the y-axis, and then there's this rotation. Same thing is true up there for the square root. But this is good enough. The main thing here is that you know what it looks like. Exponential graphs. You've probably seen these in Algebra 1, and so this is the upward curve. This is where it grows really slowly at first. And then all of a sudden there's this breaking point where all of a sudden it starts a quick growth. So the general format is y equals 2 to the x. Y equals a to the x. We're often just for teaching purposes, we're going to use y equals 2 to the x. And there's also this graph called the logarithmic graph. You may have never seen this before if you're in Algebra 2 for the first time. This graph is actually the opposite of the exponential graph. It's the inverse of that graph. And so here you see quick growth, and then that transforms into what? Slow growth. Slow growth. Then we get into sine, cosine, and even tangent graphs. And you can imagine how the sine and the cosine graphs might work. There's lots of things in the natural world that are repetitive. Seasons, the phases of the moon. My mom back in the fall had open heart surgery, and they went in, they opened her chest up, and they replaced a faulty valve that was in there, and then I remember going to see her after it was over, and you could watch all the machines, and they had I think it's the EKG, right? I think that's the name of it, and I'm not a doctor, I'm a mathematician. So they had, and I could see, you would see the repetitive nature of her heartbeat after it had been fixed. And it was just a beautiful thing. These types of equations, the sine graph, the cosine graph, they're used in all sorts of things in real life. You haven't seen much of it up to this point in your life because, hey, you're just doing Algebra 2, but you're opening up some new doors now. Okay, so this is the basic shape. Now, what's interesting here is that this goes on forever. Okay, so it repeats forever in both directions. That's left and right. So what I'm showing you here is just one snippet, which we call a period. From beginning to end, this is known as one period. And then the cosine graph is the same way. Y equals the cosine of x. If you can look here at the next graph, the tangent of x, it too is periodic. You see the basic graph right here, and then it just repeats itself over and over and over and over and over again. Where in the world is this used in real life? At the top of my head, I can't think of anything. I'm sure you can Google it. Okay, so now kind of the next skill that I'm looking for is for you to identify a function that best fits a scatter plot. Okay, this is going to be utilized in the next series of lessons that I'm going to be showing you, Unit 3B. So you're basically, for these problems, we're going to emphasize linear, quadratic, and exponential graphs. So, you know, I think most of these will be obvious, but there are some that are not so obvious, and they're more left up to you for discussion and open to interpretation. Yes, ma'am. So what do you say this is? Let's go ahead and answer. What is this?
Quadratic.
Clearly quadratic. Okay, go ahead and label these. You got linear, quadratic, exponential. Those are your options. So just go ahead and label those on your. So the first one, what is it? Linear. What's the next one? All right, and then last two. What does this one right here look like it's going to be? Probably linear. Let me ask you, could this actually be quadratic? Could you have a parabola that does this? Yeah? See what I'm saying? So it could be quadratic, but most people in this case would probably select linear. What we're going to be getting into here in the next series of lessons is this sort of concept. You're looking at a scatter plot. To our eyes, it might look quadratic, but as it turns out, it's actually exponential or something like this. Okay. So most people would say linear for this. And what do we think this one's going to be? Quadratic. All right. So these covers the first two skills involved here. Parent graphs, parent equations, their descriptions, and then also identifying what graph is probably best going to model a scatter plot. So thank you for watching.